We've established some simple rules for integrating or finding the antiderivatives of relatively simple functions. Now we want to start expanding on that with our first integration technique, which is integration by substitution. To help us catch on to when this is the appropriate method to use, we first want to look at identifying integrals with composite functions. So we want to consider each of the following indefinite integral problems. Which is again differentiated from a definite integral because we don't have an upper and lower bound on that integral sign. So rather than finding just a number, we should be looking for a function. We can see in our first expression the antiderivative of 6 times the quantity 6x plus 5 to the 5th power. We have an interior function, 6x plus 5, and if we take the derivative of that expression, we get 6, which matches up with this other piece of the expression. That's going to be an important piece of this integration by substitution process. In the next example, we have 9 divided by the quantity 9x minus 10. 9x minus 10 in this case is the interior function. And if we take the derivative of that expression, we get 9, which matches up with another part of this problem. Then we have 4x cubed over x to the 4th plus 9 cubed. The interior function here is x to the 4th plus 9. If we take its derivative, we get 4x cubed, which again matches up strategically with another part of the problem. And in the last one here, we have the indefinite integral of negative 4 e to the negative 4x. Negative 4x is that interior expression, and if we take its derivative, we get negative 4, which matches up with that coefficient out front. What we're going to do with this process called integration by substitution is use these relationships that we've established here by taking the derivative of those interior functions to rewrite each of these expressions. In the case of the first one, we'll end up rewriting this as the indefinite integral of u to the 5th power, which, if you kind of squint your eyes, you can sort of see where that's coming from, but we'll get into how we do that. The second one we'll end up rewriting as the integral of 1 over u du, and then the integral of 1 over u cubed du, and the integral of e to the u du. The process, which has some additional steps we haven't covered yet, has the ultimate goal of taking a more complicated function that we want to find the antiderivative or the indefinite integral of by first rewriting it in a form that matches one of our simple rules that we have for finding antiderivative functions.